As the world transitions away from fossil fuels, the automotive industry is at a crossroads. Battery electric vehicles, BEVs, have surged in popularity, driven by improvements in range, charging infrastructure, and cost. Meanwhile, hydrogen cars, once hailed as a potential rival, have struggled to gain traction. This episode of Tomorrow's Ordinary, the Future Audit investigates whether hydrogen cars can still compete with BEVs, examining the evidence from industry experts, technological benchmarks, and real-world applications. We will explore the strengths and weaknesses of both technologies and consider where hydrogen might still have a place in the future of transport. Can hydrogen cars still compete with battery electric vehicles in the near future, given current technological, economic, and infrastructural realities?
To several hours at home. It's getting better, but it's still time-consuming. Now here's where hydrogen shines. Refueling takes just 3 to 5 minutes, just like a petrol or diesel car, super convenient. But here's the problem, infrastructure.
Hydrogen cars can be refueled in minutes, but their practicality depends on infrastructure. Hydrogen cars can be refueled in 3 to 5 minutes, similar to petrol or diesel cars, which is significantly faster than the 30 minutes to several hours required for battery electric vehicles. However, this benefit is only useful if hydrogen refueling stations are widely available, which they are not. In a future where hydrogen refueling stations are widespread, hydrogen cars could become the preferred choice for long-haul trucking and commercial fleets. They might offer the same convenience as traditional fuel vehicles, making them ideal for time-sensitive deliveries and transport. This could be a game-changer for industries where time is a critical factor, such as logistics and freight. Currently, battery electric vehicles have a rapidly expanding charging network, making them more accessible to the average consumer.
Battery electric vehicles currently convert roughly 77% of grid energy into actual motion at the wheels. Hydrogen fuel cell vehicles, by contrast, convert only about 25 to 35% of the...
Battery electric vehicles convert 77% of grid energy into motion, while hydrogen vehicles manage only 25–35%. Battery electric vehicles convert approximately 77% of grid energy into motion, according to studies from Zemo Partnership and other sources. In contrast, hydrogen fuel cell vehicles convert only 25–35% of energy into motion, due to inefficiencies in production, storage, and conversion. Imagine a future where hydrogen vehicles dominate, but their energy inefficiency could lead to higher fuel costs. This might result in greater reliance on fossil fuels for hydrogen production, undermining the environmental benefits of the technology. As battery technology improves, BEVs could become even more efficient and cost-effective, reinforcing their dominance in the consumer market. While hydrogen vehicles offer zero tailpipe emissions, their overall energy inefficiency makes them less viable for mainstream use compared to battery electric vehicles.
Clearly have the edge. But hydrogen may find its place in heavy-duty transport like trucks, buses, and even airplanes, where fast refueling and longer ranges matter most.
Can hydrogen power the future of heavy transport? Let's explore its potential. Hydrogen fuel cell vehicles, FCEVs, are being explored for heavy-duty transport due to their high energy density, zero emissions, and fast refueling times. The UK currently has fewer than 6 hydrogen refueling stations in regular operation, compared to around 100 across Europe. Imagine hydrogen-powered long-haul trucks becoming a common sight on UK motorways, refueling quickly at strategically placed stations. These vehicles could help reduce emissions in sectors where battery electric vehicles are not yet viable. However, this future depends on overcoming infrastructure and economic challenges. Research suggests that by 2050, battery electric vehicles may dominate the HGV sector, with hydrogen playing a niche role in long-haul and heavy-duty segments.
The cost of operating a hydrogen fuel cell car will be approximately the same as operating a diesel-powered car today is. That's a huge advance in not so many years.
By 2030, could hydrogen cars match diesel in cost? Let's explore the numbers. Currently, hydrogen fuel cell vehicles are more expensive to operate than battery electric vehicles due to higher hydrogen production costs. According to a 2023 report, battery electric vehicles have a clear cost advantage today over fuel cell vehicles for large premium SUVs and vans. Imagine a future where green hydrogen, produced using renewable energy, becomes more affordable and widely available. If hydrogen production scales and costs decrease significantly, fuel cell vehicles could become more economically viable by 2030. By 2030, the cost of operating a hydrogen fuel cell car might match that of a diesel car, making it a competitive option. However, this is an optimistic projection that depends on significant advancements in hydrogen production and infrastructure. The evidence suggests that hydrogen cars, while not a direct competitor to battery electric vehicles in the mainstream passenger car market, may still have a role to play in sectors where BEVs face limitations, such as long-haul freight, heavy transport, and aviation. However, for the average consumer, battery electric vehicles remain the more practical and efficient option at this stage. The future of hydrogen will depend on continued investment in production, storage, and refueling infrastructure, as well as the pace of technological and economic progress. As we move forward, the coexistence of both technologies may be the most realistic path to a sustainable transport system.